Well, we're going to start this session, and I'm Enrique Prunez with the World Wildlife Fund. I'm the Rio Grande manager and freshwater lead specialist for the freshwater and food team based in Washington, D.C. And today, along with my great colleague Brian Richter, we're going to be talking about the work we're doing to restore the Rio Grande Bravo. So just to put this into context, for those that are not familiar or not so familiar with the Rio Grande Bravo basin, is this binational basin between the US and Mexico. It runs for 3,000 kilometers from Colorado State to the Gulf of Mexico. And for 2,000 kilometers from what you see in the map in El Paso to the Gulf of Mexico, it forms the border between the US and Mexico. It encompasses 5 terrestrial ecoregions. It's part of the southern part of the Great Plains, temperate forest in the headwaters, but also the Chihuahuan Desert in a region where we have focused our efforts for some time. And just to put a note here, it is a neighbor to the Colorado River. The Colorado River gets a lot of attention, but the Rio Grande is facing similar challenges. But it's different in the sense that the basin is split almost half and half between the US and Mexico, whether the Colorado River is 95% or so of the basin in the US. So I was talking about the Chihuahuan Desert. It is one of the 3 most biodiverse deserts in the world. There are some numbers there, just a reference to the number of species of plants, mammals, fish, birds. And in terms of the people, the culture, it sustains 16 million people, 5 million people in the US, 11 million people in Mexico, including tribal nations and pueblos and indigenous groups. And there are 3 states in the US, Colorado, New Mexico, and Texas, and 5 states in Mexico. But the river has been designated as one of the 10 most endangered and water-stressed rivers in the world. As you can imagine, it has a complex and fragmented water management and governance. The river has lost 80% of its natural historic flows, and of course is no exception to climate change. Climate change and rapid population growth are exacerbating these water challenges in the basin. And the demand for water, mainly for agriculture, is greater than what the river provides. So there are more water rights on paper than actually water available in the basin. And the result is that it is a river that dries up in many stretches, and that is struggling to reach the Gulf of Mexico in many years. So again, this is a heavily managed and over-allocated basin. So there are 4 main water-sharing agreements, 2 international treaties between the US and Mexico that mandate or rule how water is managed between the countries. Is the Convention of 1906 and the perhaps most known Water Treaty of 1944. But there are 2 interstate compacts. One for the Rio Grande between Colorado, New Mexico, and Texas, and one for the Pecos River between New Mexico and Texas. There are around 18 irrigation districts throughout the basin, and agriculture takes 85% of the water that is being used in the basin, mainly for cattle feed crops. This is taking most of the water, and we're talking about alfalfa here. But then cotton and pecans are the other main crops. There are other crops throughout the basin, but those 3 are the main ones. And I'm just going to stop a little bit here on the map. You will see that there are irrigation districts, and then those in orange, and then in red you have those wild and scenic rivers, and then you will have more irrigation districts and dams, and there what it says, Fort Quitman to Presidio, it is what is called the Forgotten Ridge, which is a stretch of the river that is dry, that dries up completely with the exception of extreme monsoon years. So you will see this pattern of extraction, depletion, protected areas throughout the basin. And which is part of the work we're doing. We recently completed with the support of Dr. Ning Liu and Peter Cadwell from the US Forest Service, what we think is the first basin-wide hydrologic model to understand river depletion throughout the basin and potential management options to improve river flows. So on the map, you see different levels of depletion by sub-basin. In some places, it's more intense than in others. And the figure there, it's some work we're doing with the University of California. We're going to talk about it later, but we have that kind of information for 42 gauges throughout the basin. And what is there is in the blue color, the blue line, is the natural flow, the natural hydrograph of the river, how it used to be pre-development. This is 1900s. And the red line is the regulated or the observed flow, so how the river is now. And that is just an example for 1 gauge in New Mexico, but you will see the difference, and that's the depletion of the river. So what are the impacts of this? In terms of ecological impacts, at least 75 species are imperiled by river depletion, and that are multiple socio-economic impacts. For example, in 2021, 2022, water deliveries to the southernmost irrigation district in New Mexico were shut off in June, months before the end of the growing season. Similarly, New Mexico is struggling to comply with the Rio Grande Compact. And maybe you heard on the news back in 2020 that Mexico was struggling to deliver water to comply with the international treaty for the US and also to the lower states in Mexico. So those are some of those examples. So as a conservation organization that we care about the river, biodiversity, ecosystems, the people that live in it, what are we doing, what are we going to do, or what are we doing already? We have worked in the basin for over 20 years now. A lot of work in the Mexican portion, the Big Bend region. And then 4 years ago, we took a step back to rethink our conservation strategy for the basin, our 2020-2030 conservation strategy, building on all the work that we have done. And that included just rethinking a little bit about the vision. What do we want for the river? And it's still about restoring connectivity, ecological and hydrological connectivity through these socio-ecological pearls, through binational collaboration, convening stakeholders, strengthening water governance to sustain biodiversity and communities. So I mentioned this string of pearls, and maybe you're wondering, what is that? What are those string of pearls? And we just use this concept of the string of pearls as a foundation just to conceptualize our strategy for the coming years. And where the string of pearls are is throughout the river, even though it's depleted in some water challenges, facing some water challenges, there are places, stretches of the river throughout the basin that still sustain important ecological functions, or that has good ecological integrity, or that sustain endangered species, or that are protected with protected areas or wild and scenic rivers. But then you have irrigation districts, dams, and water management to comply with these treaties and compacts. And the string is a more environmental friendly pattern river flows that could connect or wave those strings. On the map, you will see that those red dots are just examples of where are those string of pearls. You will see where it says Big Bend. That's the Big Bend National Park, and then a complex of protected areas in Mexico, which is a UL at the core of the Chihuahuan Desert, just like as an example. And part of the work we are doing, to convene stakeholders and just foster this shared vision, we developed this Basin Health Report Card in collaboration with the University of Maryland, the University of Massachusetts, and Audubon. And what these report cards are, this Basin Health Report Cards is a tool that we have developed in collaboration with the University of Maryland, and we have implemented this tool in multiple basins around the world, in places where WWF works. And the process of the report card is to host a series of workshops, meetings, with stakeholders representing different parts of the basin and different sectors, private sector, NGOs, government. And for this case, we did it for the Upper Rio Grande, which is Colorado to Fort Quitman. And we had the participation of 100 stakeholders representing 63 organizations from Colorado, New Mexico, and Texas, which it's not easy to bring people from different states to discuss these shared values and threats. And after that, the result or the purpose of this is, once you identify values and threats with the people that know and care about the river, you develop indicators to assess the basin health. And then we gather data to score those indicators based on science. And in this case, we ended up with 26 indicators for management and governance, society and culture, landscape and ecology, and of course, water quantity and quality. Those indicators are scored as a school report card from an A to an F. A is very good, and F is very poor, just as an easy way to communicate that to the general public decision makers. And you will see that some indicators are doing better than others, but everything that is related to river flows, annual low flow, or zero flow days, those are days where the river dries up, or flow alteration, even groundwater, impaired streams, and even water supply for agriculture are not doing great. Overall, the score for the Upper Rio Grande was a C, which is a moderate condition, but scores vary throughout the basin. So we assess different regions, like in Colorado, upper part of the basin in New Mexico, middle Rio Grande, New Mexico, the lower part in New Mexico and Texas. And the scores vary throughout the regions, but scores do worsen from north to south as the river gets depleted. Again, if you remember that figure with the natural and hydrograph and the regulated hydrograph, once you get to El Paso, the red line is a flat line. It's almost a dead river. And then finally, with the University of Massachusetts, for the first time, we combined what they developed as a freshwater resilience by design methodology with the report card process to not only have a snapshot of the basin health, that are those indicators, but also to bring some future scenario modeling to understand what are the future scenarios of the basin and the potential management options to raise the grade or improve those indicators that you saw on that colorful indicator wheel. And most of these conditions can vastly improve by restoring river flows. So with a subset of stakeholders, and particularly water managers from state and federal agencies and irrigation district, we discuss what are those potential management options that we can implement to improve these conditions. And on the y-axis, you will see some of those management options, like reduce irrigation losses, conveyance losses, or reduce water demand in agriculture through fallowing, crop shifting, or reduce municipal water use. Although cities have done a great job to reduce per capita water use despite population growth. Or what if we just maintain minimum ecological flows as a rule to operate the system? Other option was reoperate reservoirs to increase upstream storage in higher altitudes to reduce evapotranspiration. So then we assess all of those options in a sort of trade-off analysis to see if you do one option or a combination of options, how that improves or not those indicators. For the most part, you will see that this can be vastly improved by again, restoring river flows. So that is just setting the stage of the river that is. A river that has depleted, that has lost a lot of its historic natural hydrologic elements, like spring pulses or minimum flows during the summer or dry seasons. And the river we want, that vision of reconnecting the river to, or having a flow regime that is more resilient, that can continue to sustain those ecological perils, and also help water managers to deliver water and comply with these sharing agreements, and also to sustain farming and the communities that live in there. So we have worked hard on thinking the strategy, but also putting numbers to this. Like, how much water do we need to restore? Like, what are the targets? What can we do? And we have spent 4 years now working with different researchers to understand and get answers to these questions. And Brian is going to walk us through that.
Thank you, Enrique. So what Enrique and I really wanted to share with you today is a real-world example of how do you actually change the health, the condition of a river system and the communities, both natural and human, that depend upon a river system. So I'm going to walk you through the analytical process that we've gone through. I'm going to give you very, very high level and skip over things in the interest of time. But that's what we're trying to do here, is to really illustrate how we can actually do this. And what I'm going to summarize for you is the analytical phase, the science that went into understanding how much we need and how can we get it. And we are now on the verge of moving into operationalizing that, moving into implementation with the local communities. So basically, so the first step was, I've got a series of just a couple of questions that we're going to talk about. But I also want to emphasize we brought in a lot of collaborators on this from many, many different universities, different organizations to be collaborators on this. And so the first part I'm going to talk about is just how do you define how much water you want the river to have? What kind of river do we really, really want? And so, oh, that's interesting. The animations aren't working. Okay, we'll adapt. Okay, so basically Enrique showed you this slide before. It's covered up a little bit of animation, but essentially the concept here, the theoretical concept here is there was a time when this river system was operating largely within what you might think of as a natural range of variability. And what the other slide that I wanted to show you would have shown is we've statistically characterized different aspects of the river flow regime and looked at how those characteristics changed over time, and at what point in time did they begin to depart from the characteristics that this river had originally, okay, in its early years. And so we base then the desired condition on what those characteristics were prior to the time when the river became much more heavily altered. So that's how we've defined that. That's what we're calling the resilient flow regime. There's a whole bunch of numbers and graphs here, so don't get confused by it. The only reason we're showing you this is by characterizing what the resilient conditions, the desirable conditions are, we can then look at how much different is that from the current conditions, and we can actually quantify how much water needs to be retained in the river beyond what's presently that exists there, and quantify that. We call that the environmental flow gap. And then that gap becomes our target. That quantified gap becomes our target. And it's a different target at different times of the year. And it's not just volume, it's also time of the year. As Enrique showed you in those other graphs, this is a massively altered river. And it's having terrible effects on not just the river ecosystem, but also on the human communities dependent upon this river. We've been in a 22-year drought. The last 2 decades have been labeled or identified as the driest 2 decades in at least the last 1,200 years. So let that sink in. The driest 20 years in the last 1,200 years. And people are suffering, and the river ecosystem has been suffering. So what we're looking at here is what can we do in the context of a changing climate and overuse, what has now become overuse of the river basin, to try to improve things both ecologically, environmentally, as well as particularly for the farming communities that are dependent upon this. Because remember what Enrique said, the last 2 years, the farmers in the southern part of New Mexico received only 5% of their normal allocations, and they had to stop irrigating after June. And obviously, they have a lot more growing season that they would have liked to grow their crops or finish their crops. So this is a quantification of the flows. Let me back up. So the part that we're really interested here with the example that I'm going to show you, and our starting point is in those summer and fall months of the year. These are months of the year where you do get a little bit of monsoonal thunderstorms that help the river a little bit. But it's also the time at which irrigation is taking as much water as they possibly can out of the river system and causing it to dry up. So that's the time of the annual hydrograph that we're really focused on here. So we've quantified this. During that time of the year, we need to reduce consumption, I should say, by about 23% of the current level of consumption. That comes out to, here in the US, we use acre feet, so it's over 17,000 acre feet, 21 million cubic meters. And that's a high challenge, right? That's a high bar. That's a big task to try to reduce consumption by that amount. So how are we going to do that? This is the next question we're trying to address. Because of the way that water is being used presently, there's no way to solve this problem without a substantial attention to irrigated ag and how water is being used in agriculture. It's 86% of the water use on the U.S. side of this river basin. So if we're going to try to reduce or create more water for the river, then we absolutely have to be focused on irrigated agriculture. And as you can see there, there's some of the distribution of some of the crops that are involved. So we've used, Enrique mentioned that we built the first whole basin hydrologic model. Kind of remarkable, right? That in the 2020s, we didn't have a full hydrologic model for the entirety of this river basin, but that was the case, and largely because, of course, the international boundary, that we didn't have the kind of data sharing, modeling going on between the two countries. So we took that on and we built that model. And that model enables us to look at things like, well, if we reduced irrigation by 10%, what would the river look like in different parts? By 20%, by 30%. And that was really important to our coarse scale screening or filtering of what the potential would be or what the requirements would be to put this river back into the condition that we are seeking. Then the question was, okay, we got numbers now, and we got kind of a ballpark on how much we need to reduce the irrigation use by. We've now been working with a really remarkable team, primarily out of Virginia Tech and out of University of Delaware. These are global experts. These folks do amazing work on agricultural water consumption, really have pioneered the whole concept of blue water consumption, particularly for agriculture, and doing some really, really terrific work, which I'm going to share with you very briefly here. One of the things that they've done, so some of you probably saw the session yesterday afternoon on OpenET, and you heard about the level of resolution and that sort of thing, that they're able to now quantify water consumption on very, very small scales, 30 meter by 30 meter. One of the limitations, that is a remarkable breakthrough technologically. And we're comparing a lot of our work with the results out of OpenET with very positive, very good correspondence or correlation. What we've been able to do is go back to 1980 and model every single month's irrigated crop water consumption for every month from 1980 to 2019 and been able to do this for each individual crop over that time period. So it gives you a time series and you can see how things have changed over time, and it really helps to inform our analysis of potential strategies of how we want to modify the distribution or the mix of some of those crops. And so you see there on the graph on the right, this enables us to look at those kinds of trends. In this basin, alfalfa has gone up pretty substantially since 1980. Pecans have gone up somewhat. That's the line on the bottom. And that has had consequences for the river. There's been a lot of dairy production move into parts of the western United States, and it's very water consumptive, and it actually has increased the utilization, the production of and the utilization of alfalfa, which is having big consequences for water scarcity in western river basins in the United States. And that's very much the case here in the Rio Grande. So we then did what we call a crop optimization analysis. In other words, if you were to ask the question, what would be the optimal mix out on that agricultural landscape, and you're looking at it from the perspective of we're shooting for a specific reduction target, reduced consumptive use, as I said, of 23%. How are we going to get that? And so optimization enables us to do that kind of analysis, and this underlying data set of the crops on a month-by-month basis helps us to conduct that analysis. So the primary objective, as you see there, reduce water consumption through a combination of strategies by changing the mix of which crops are being grown out there and also with introducing some degree of fallowing. And fallowing, for those of you who don't know, is basically just resting the field for some duration. It could be for a year or two, or it might be permanent retirement of some of the agricultural lands. But here were the constraints. We wanted to make this palatable. We wanted to make it reasonable. We wanted to engage the farming community with this, and we're going to be working, have been working very closely with them, as Enrique shared, and will continue to do so. Really important to maintain their revenues, maintain or improve their revenues. So that was kind of like that's sort of like a red line in the sand. We were only going to use crops for this optimization analysis that have been grown already out in this area. At least 10% of the irrigated acreage had to be using this crop for us to introduce it into the optimization analysis. We could have thrown in some wild cards that are actually very, very exciting, like guayule now being used for tire rubber, which is a very, very low water intensity crop. But we decided to keep this as real as possible just to get this conversation going about what a more desirable mix of crops might be like on the landscape. We set limits on how much any particular crop could be reduced, and we looked at how our optimization would change if we set a limit on only 5% reduction as opposed to a 30% reduction. And then lastly, we looked at a range of fallowing. So we set limits. If you did no fallowing, what could you get? If you went as high as 40% of the irrigated acreage, what would that look like? So you get a picture here. We're running a bunch of different scenarios with a whole bunch of data and seeing what comes out of the hopper at the end. So this idea, I just wanted to spend this slide on this concept of crop shifting. So just to illustrate with two crops that are actually very, very important to this story in the Rio Grande, we're looking at two things. How much water does it consume, and how much net revenue are the farmers making by growing that crop, okay? So you look at alfalfa, you see the numbers there for blue water consumption. You can compare it to the green chili peppers, which is a very, very important crop in New Mexico. 19% less water consumption by the chili peppers as opposed to the alfalfa. That's good. Net revenue, really important. Look at the differential there. So 20 times more revenue per unit area coming off of the chili peppers. So that makes this kind of a crop shifting combination pretty attractive, right? You can make a lot more money using substantially less water. That's just to illustrate the concept of what gets thrown into the mix of this optimization exercise. So here's some results, a little hard to see. Let me walk you through it. If you don't do any fallowing, because of the existing crop mix that's out there, there's not a great diversity of crops being grown. It's dominated by alfalfa production and other hays, other grass hays. There's some pecans, some cotton, some chili pepper, and that sort of thing. If you just said we're not going to intentionally fallow any more ground, you're going to be limited to about 10% water savings. So we're only getting less than half of the distance that we need to get through strictly crop shifting with no fallowing. If you introduce fallowing, then all of a sudden you're opening up a lot more possibilities, as much as a 40% reduction in crop water consumption. The two green bubbles there represent 23% reduction. That's our target, remember? That's what we're shooting for here. What's great about this kind of an optimization is you can see different scenarios and different opportunities. So for instance, if you allow any individual crop to be reduced by as much as, say, 25%, then you would only need to, then you could save that 23% and you could get away with only fallowing 18% of the agricultural land. If you're going to be more restrictive on how much of any individual crop you're going to reduce, for various reasons, you don't want to be too disruptive to supply chains and that sort of thing, then you're going to have to fallow more to match up with that, okay? So that's the basic concept here, but we were very heartened by the fact that this is possible. It is possible to recover these volumes of water. So I mentioned fallowing, and I want to just want to say something about this, because people usually wince when they hear fallowing. It's like, aren't we trying to grow food for the world? Don't we already have food shortages? We don't want prices of food to go up substantially, all those things. The thing that very few people actually realize and acknowledge about farming in the water-stressed areas of the world is that farmers are being forced to unintentionally fallow quite regularly, and in this particular basin, far more than 18 or 20 or 30% of the land is getting fallowed unintentionally because there's no water to put on the crop. They can't finish the crop. So that's important to understand, because if you start talking about intentional fallowing, you have to keep that in the backdrop. Under climate change, under what we're going through over the last couple of decades, those crops aren't getting produced anyway, and we would like to suggest that if you're more intentional about that, and you think about which crops you might want to fallow and what parts of the basin, maybe the more marginal cropland that's less productive would be, your target. It might stimulate some conversations about sort of land use planning or agricultural land use planning. Can you really optimize this landscape, and how do you get to that? So you can do that in a much more thoughtful way. Bunch of numbers here, but just to say that in the optimization runs, again, because we've got a limited diversity of crops available to work with, alfalfa presently takes up about 78% of this area that we're looking at. And so depending upon how much you reduce the alfalfa, you have to make it up with other crops. And chili peppers in particular, if you're going to lose the revenue off of alfalfa, you can shift over to chili peppers and increase its acreage from it's really more like, it's a little bit higher than 0% presently, but you can get up to maybe 10% of the acreage being in chili peppers, and that helps to make up some of the revenues and provides an alternative for some of the farmers to switch between those two crops. So we're looking at a lot of different scenarios this way. Last slide. As I said, we're on the precipice now of moving into making this operational and going into implementation, and so we're thinking a lot about how do we work with the farm community and bring opportunities to them that can help them make some of these transitions, whether it's going to a different crop or whether it's temporarily or more permanently fallowing some acreage. And we're looking at everything, particularly at the federal and the state level. Federal Farm Bill, obviously, crop insurance programs, perhaps some of that money could be redirected at preventing crop disasters rather than compensating entirely, as part of the Farm Bill. But there is other funding in the Farm Bill to help to incentivize or compensate farmers that want to go through that transition to a different crop. The Inflation Reduction Act is also providing some funding for that. There's some bills being advanced by the representatives in New Mexico that would bring some funding to aid doing these kinds of actions. Corporate water stewardship programs. Enrique's been very, very involved in and now has just launched a corporate water platform for the Rio Grande that is going to enable some of the corporates to come in and help with some of these challenges. And also we're very attentive to the need to expand some markets so that if we're going to talk about crop shifting, there's got to be a market for the crops that you're shifting to. All right, that was a very quick run through. I don't know how we're doing on time. I guess maybe we have a few minutes for questions perhaps. Okay, please.
Perhaps I came in a few moments late, so that maybe this was mentioned. You were working with it's not a hypothesis, it's fact. 86% of the water in the Rio Grande is utilized, top things, feed for cattle, almonds and cotton, correct?
Yeah.
So now you're
Cotton and pecans.
You're
Yeah.
discussing how we can decrease that consumption, target being 23%.
Yeah.
How about
Yeah.
the remainder of the water consumption? Do they also have to decrease, such as development, do they also have to decrease by that target?
So Enrique alluded to this actually, maybe perhaps, no, but in passing. We have the data from each of the large urban areas that are within this basin as well. They're actually doing a remarkable job over the last 20 years. While their populations have grown substantially, I don't have the exact stats, but anybody who's interested, I do have a paper that we just published on this. While their populations have grown substantially, they've actually been able to reduce their water use rather than even keeping it steady. So, growing 10, 20% in population, and yet their water use today is 10 to 20% or more less than it was 20 years ago. So they're pushing hard.
That's not what I asked.
Yeah.
Is it a proportional decrease based upon their percentage they use as the agricultural?
That's a very, very good question in terms of sort of equity, right, across the different water use sectors. I think that's a great conversation, and it's one that through this report card process and this collaboration with a lot of stakeholders, those are the kinds of conversations that we have to have. But absolutely, with your point, I completely agree that this has to be an everybody in, all in, equitable approach. So we're not putting the thumb too heavily on any one particular group of water users. And that's within the crops too, by the way, of course. Sure, and then I'll come to you. Yes, go ahead.
Mike?
Yeah.
Thank you so much, Brian, for the presentation. Now, you obviously are way more experienced in this game than I am. Of course, I just started my career. You have some really good points, especially when you mentioned the 23 current, reduction in consumption
Yeah.
in Rio Grande.
Yeah.
And we're talking about sustainable diversion limits here.
Yes.
Right. And
Yeah, you must be from Australia.
Right, well,
Or familiar with it.
you'd be surprised
Yeah.
how much I know about Australia, one of my So you are right on point
Yeah.
on the sustainable diversion limit.
Yeah.
But where I feel that you are sort of changing direction is that you're focusing on crop shifting.
Yeah.
However, I'm interested in growing cotton.
Yeah.
So are
Right.
you telling my industry that you're going to block my industry? Because that is exactly what you're saying here. You're going to block my industry and grow different type of crops. Is that your direction?
Well, the reality is that all of the crop producers, all of the farmers are being hit very, very hard right now. It's not an acceptable situation. They're going through severe water shortages. They're getting their water supplies cut off early in the irrigation season. So it's a pretty horrific situation. The status quo is pretty horrific. I think it's really important to acknowledge and understand. Then the question is, what are we going to do about it, right? What we're shooting for is long-term sustainability in water use. So it's important, and there was an excellent comment made in one of the presentations yesterday. One of the speakers talked about that if we're going to talk about sustainability, it's not just about water use, and it's not just about food production, but it's also long-term economic sustainability. So how do you make a change to where the farming community can continue to stay in farming, but on a more sustainable basis? I mean, there are a lot of them that are going bankrupt right now in this basin because they don't have enough water to be able to produce their crops. So you got to do something. This is not, the status quo is not acceptable here. So that's a conversation that we need to have, and what are the consequences? And not to pick on any particular crop producer, but how do you come up with the right mix of things and perhaps some retirement of things in order to get to that very desirable economic, ecological, social sustainability here? Yes, up front.
With the success of the Curtin Water Bank Authority in Bakersfield, where they built the infrastructure to fill that aquifer back up, pulling off the canal,
Yeah.
what aquifers could be surfaced or resurfaced here or recharged with that type of technology, if any? I don't know the aquifers that are on the journey here.
Right.
But it was immensely successful, so much so. During the drought last year, prior to the rains, the authority and the farmers saved $200 million at water prices that were exceedingly high that year. I'm really curious to see how can that success story be implemented for those farmers in critical areas where aquifers do exist, but the infrastructure hasn't been built out.
Right. Enrique, Enrique has done a lot of work on groundwater and aquifers in the basin.
Yeah. So actually, WWF, we have done a lot of aquifer recharge work in the Mexican side. We have an aquifer recharge strategy for the Chihuahua state, for the Conchas Basin. We are working with the water authorities there to scale this aquifer recharge management options. And I think there are a lot of opportunity to do something like that in everywhere throughout the basin. There are multiple aquifers. I don't remember all the details. Some are doing better than others. Actually, in Colorado, they are doing a lot of work on just recharging the aquifer and trying to stabilize groundwater level declines. So I think there is a lot of opportunity to.
And I would definitely highlight the San Luis Valley in Colorado plays desperate.
But it all
Yeah.
comes down to pull during the wet years, park it so that you
Right.
can pull it out during the lean years.
Yep. But they are struggling. Their target for recovery is being required by the state, which has sustainable water management plans, essentially. Not exactly like California and the Central Valley, but they have set a target for recovery of the aquifer levels, and they are not getting there. So because of this, mega drought, this extreme situation. Back there, and I think I saw a hand over there. Yes, in the back.
I think I have two questions.
Yeah.
So one is the area that you're going to fallow. Is that different than like putting it in a conservation area? And what strategies can you use to make the most of that land? And maybe that's for aquifer recharging or something to really get the most out of the fallowing. And then also, if you're replacing alfalfa, which I guess is for cattle, is there a more sustainable crop that can be used instead for cattle?
Yeah, great. Okay. Two tough questions. But so I wish that Maurice Hall from EDF was here. I know Rachel is, and might want to look for Rachel to talk about. They've been advancing a land repurposing program in the Central Valley, and now they've moved into the Rio Grande. But it's that idea of what, if you are going to permanently retire it, what do you want it to turn into? You don't want it to turn into, a weed-infested dust bowl, right? And so there's a lot of discussions, and in the Central Valley, I think it's probably one of the more advanced conversations about that kind of concept. But basically, in some cases, it's sort of restoring it to some wildlife habitat or to some wetlands or riparian forests. In other places, it's talking about going to agrivoltaics or just basically solar farms. That's a great conversation to have, and has to be done, with the kind of collaboration of the community stakeholders, to talk about that. So great question. And I would look at some of the literature that's coming out of the Central Valley as some illustration of that. On agriculture, that's a particularly tough one. Most of the alfalfa production in the West, at least the recent increases, as I mentioned earlier, is going to dairy production. So I think it opens up a question, is the West the best place to be increasing dairy production? There are dairy farmers going out of business in Wisconsin, right? So sort of like, why is this happening? And I'm not sufficiently, understanding of why that sort of trend has been occurring. But that's sort of one issue, are the feeds that are required more available in different parts of the country? The Rio Grande is less than 2% of the country's alfalfa production, so it's not like, it's not an enormous hit, but still important, and still important in the supply chain. So you got to be very conscious, and these are long-term strategies. These aren't things that you do, overnight with that kind of disruption. So it's a terrific question. I wish I had a better answer for you. I know there's a lot of interesting research going on about different crops that might be suitable feed substitutes, and it's an interesting area, but I'm not knowledgeable enough to answer your question honestly. Yeah, yeah.
I think we're on time, but just to add to that, it's very interesting that the Middle Rio Grande Conservancy District in New Mexico, they actually started 2 or 3 years ago a pilot of a fallowing program. They are already piloting and just receiving applications from volunteer applications from farmers that would like to follow, and they received some payment, and they have been doing that for the last 2 or 3 years, and they're just exploring how that could work already. It is an initiative from the Irrigation District with some support from the state water agency in New Mexico, and that's where they are. They are just exploring and testing because they're at the same time, as I mentioned, struggling to comply with these compacts, and that's very tense situation between the states, and they are just exploring some of those options. I think we're on time. I don't know if we have time for. Oh, okay. Okay.
Well, hey. All right, now we get a question over here, and then Hugh
Yeah.
will come to you.
Yeah.
Yes.
You want-
Hi, I've been listening to the questions that are being asked around the room, and to me, I think about it in terms of a statistical model. So you're presumably you have some sort of parameterized model that is incorporating your objectives.
Right.
And so I think a lot of these questions relate
I'm going to let Brian get that question on the revenues. I'm just going to say that, again, in the past 4 years, we have been thinking, like, what are the targets? We have a depleted river. What can we do? We need to do some assessment on, like, different crops and options. And so we are getting there. And there's, I think, definitely a lot more to unpack and understand before implementing or doing some of this, implementing some of these management options. So I think eventually we'll need to get to those kind of more detailed analysis. So yeah.
Yeah, thanks for the great question. And the issues that you're raising we're very, very cognizant of and very attentive to, and with the intention of doing everything we can to sort of facilitate or be a part of that conversation. And I think a key part of it, the reason that we wanted Enrique to talk about the efforts that have been put forth of bringing the stakeholders together for the conversation, that's just a starting point. I don't think anything like this can succeed without having a very, very high level of community engagement. The irrigation districts have signaled that they're really, really interested in this work. They want to see, because they're in desperate straits. They're not meeting their compact obligations to send enough water downstream into Texas, and that's causing all kinds of legal problems for the state of New Mexico and for the farmers. The farmers aren't able to store any water while New Mexico is in arrears to the downstream state. So this is a really, really dire situation. And in that crisis, we're hoping that it opens up some interest for engaging in the kind of conversation that you're suggesting, and that we can understand more about, what's the nature of the supply chains? What are those contracts like? If you shift from this, what kind of support might you need over what kind of a transition? But a little bit more on that. Chili pepper production has gone down while alfalfa production has gone up. So a lot of these farmers were producing chili peppers prior to growing alfalfa. But we need to understand that better. You're absolutely right. And we also need to understand, to hear from the farmers, would you be interested in doing this? How are you feeling about this? Is this a viable strategy, right? So terrific questions. And things that really models, it's difficult for a statistical quantitative model to really incorporate the kind of qualitative information and the real human conversations that need to take place about this. Hugh, I said you're going to come to you next.
Yeah, so I guess this is for Enrique. I'm really interested in your thoughts on corporate involvement. Because I have to think that, like in most areas around the planet, the issue is going to impact them regardless of their source of water. It's going to impact them from a reputation standpoint or from some other aspect. So I'm just interested in your thoughts on where you are on that.
So, many of you might know, WWF as other NGOs work. We work with corporate partners on this corporate water stewardship journey in many places and many basins around the world. And what we're trying to do is, there is interest from some of those companies or corporate partners to do some work in the basin, either through investing in philanthropic projects to do restoration, nature-based solutions, or just either working on their operations or supply chain. And what we are trying to do is that interest and that is already there. That exists, and we are doing it. They're doing it in many places. We're going to hear from Cargill later here. But the idea is to connect those efforts to the strategy, to what is it that the impact we can have if we direct those efforts to the basin. And the idea is just to work with them, organize in a way that we can link those efforts to the strategies and impacts that we need to restore river, to support communities, farmers, et cetera, et cetera. So that's kind of where we are. We are in a initial phase just to completing this foundational science and assessments to understand that, and that's the work ahead.
Take one more. You've had your hand up. Yes.
Yeah, as part of your consumptive use studies, is there an interest in establishing what consumptive use for the riparian vegetation is, including the invasive species like tamarack
And I just received that question a couple of weeks ago, and with one of the models that I mentioned we're doing with the University of Massachusetts, just on the overall balance, water balance for the basin, just vegetation evapotranspiration is almost equal to crop evapotranspiration. I don't know how much of that is like coming from invasive species like tamarisk, Russian olive, because we don't have that detailed assessment. So I cannot answer if invasives are a part of big part of that, or what's the share for that. But it's almost an equal share between native and non-native vegetation to the crop evapotranspiration for the overall water balance of the basin. That's kind of the numbers. Okay. Well, thank you, everyone.